I usually don't preface videos, but this is one of the most involved, comprehensive repair restore videos I've ever gotten involved in as far as vintage tube radios. This is a Grundig 3035W. I believe this is from the late 50s, and this is a West German made set. And I'm not quite sure the total run time of this video, but I think it's probably close to 2 hours. We go through a lot in this video, so all I can say is if you're into what you might get involved in restoring an old radio, check this out. This is Shango 066 for the Shango 066 YouTube channel, and thanks for watching. Enjoy. Also, this video took weeks, probably 3 to 4 weeks to complete. It's captured on 5 different cameras, including a phone. So quality and audio are going to vary through the video.
It's that kind of pure joy. Wait until you drive your first platinum certified pre-owned Mercedes-Benz from Fletcher Jones Motor Cars.
This is a 1950s Grundig kind of all-band receiver. And I've had this for a while. I put out a video initially when I got it. I haven't done anything with it. It's a model 3035, and I'm not that big of a fan of these German radios. I know I'll probably catch some heat for that. One reason is I'm not used to them. Schematics are not as accessible. Service data is not as accessible. And it's just the design of this stuff is harder for me to understand growing up on American-made stuff. So I'd like to try and get this to work. I don't know how successful I'll be. I'm sure there's some people watching this that are saying, oh, well, here's what you need to do, this, and this, because that's the standard kind of protocol for these radios. Well, I don't know what that is because I don't work on these. So let's check it out. Now here's looking at the inside, and you can see we got 3 drivers here, and these radios do usually sound pretty good, and the main reason why is these drivers are super efficient. They're probably over 100 dB, 1 watt, 1 meter. You can see we got some type of high frequency transducer there, 6x9, 2 4x6 styles. They're all real high efficiency. It's all driven by basically one 6BQ5 output. A lot of complexity with the dial codes in here. It's got these European number tubes, ECH81. I don't know, I'll show you that on the back. But basically, audio output transformer, power transformer, IF transformers. I don't know if these sets develop silver mica disease. I don't know. I don't know the pattern failures with these at all. So this is going to be kind of new to me getting into this, and I hope I just don't run into anything real hardcore. It doesn't really do anything except hum and make static. So, and also this tube was getting very hot, and it had blue glow on the inside of the glass, and I have a feeling it was right on the verge of red plating. So I want to check the coupling cap to the control grid on this first, because I don't want to burn that up. Here's the model number 3035W/3D/USA, AM7 circuits, FM11 circuits. Front end is an ECC85 followed by an ECH81, which tested dead, followed by an EF89, and then an EABC80, and then an EL84, which is also a 6BQ5. These all have American numbers. This is Grundig Majestic. So let me fire it up, and I'll kind of quickly show you what it does before I fry the audio output tube. Okay, that's on the broadcast band. That's phono. So it almost sounds like silver mica disease, although I'm not going to go there yet. I wish I knew more about these. I want to try and get it apart and spray all these switches and clean all these controls. Let me figure out how to get it apart. I did get some schematics. They're German schematics. Sam's does not cover this, so I've just got them in my phone, and they're kind of broken up and not real good. So let me get this apart. All right, so first of all, this is a really high hour set. Bunch of replacement tubes. Paper where the eye tube was is all brown. Light bulbs are burned out. And the second thing I noticed is we got this kind of fancy clutch system here, and the clutches are bad. So you can see this. Come on, you can see that's spring loaded. That's the FM. This is the AM, and the FM is just slipping because all the clutch material is gone out of here. So that would have to be fixed. The switches are all down underneath this thing. Let me try and lubricate those, but I just don't know. Got the original Grundig Siemens capacitor in it, but hum doesn't seem to be an issue, and the B+ voltages are good. So I'm not, it's a high hour set. Look at that little banana slicer right there. I do have a leaky control grid coupling cap to the audio output because I'm getting 7 volts on here with the tube out, and I cannot find the 0.01 UF capacitor that the schematic shows that isolates it. I've been through everything here. This is what I mean. Alright, I found the capacitor. It was right dead in front of me, and now our voltages are good on the audio output tube, but I was working on it. Yeah, what's up with that? Is that a filter that's like going open and closed? Come on. It's like a filter capacitor that's just going open and closed at will. But I put a disc cap in there. I know those are not good for audio, but what is this thing doing? Whatever. What's up with this thing? Alright, now we have, all of a sudden, now we have 20 volts on our control grid of the tube, and we have 20 volts on the cathode. So it's like the tube is shorting internally. Now that's a common symptom of a audio output tube that's been abused. So it's probably my fault for powering it up without changing that grid capacitor. And check this contraption out here. So you have this pulley here, and there's a string that goes up to some control on the front, and there's a slug in the IF transformer here that I don't know if I can actually do it. Let me see. See that slug that pulls in and out of the IF transformer? I wonder what kind of gimmicky tuning deal that is. Well, it blew the fuse, and I got sick of it in the cabinet, so I pulled it out of the cabinet. This is a 150 watt bulb, and it's lit up pretty bright, so something shorted, and I have a feeling it could be that selenium rectifier there on the side, unless I bump something underneath, but I don't think so. Yeah, I mean, it's an instant short. It has nothing to do with the tubes coming up. What I wanted to do is I wanted to put the could be the filter shorted too. I wanted to put the signal generator, I mean the signal tracer, on the output of the FM tuner and see if we're getting anything, but now I got this problem. So I got a shorted 6BQ5. When it gets hot, it gets leaky. Then I got a short. Oh, wow. Oh, I think I'm sorry to report that our power transformers failed. I can hear it arcing inside, and I got it all disconnected, and it's still shorted, and it smells too. It looks, you can see it looks pretty well used. Let me put the camera up against it and see if you could hear it arcing. Yeah, so unfortunately I think this thing is toast. Okay, so I don't know, this is just super confusing. So when I hook this up to the selenium, you'll see it starts smoking out of here and sizzling instantly. So it appears that what's happened here is that the secondary of the transformer has shorted to ground. Okay, so I'm on diode test, so that's 200 millivolts, but watch what happens if I push on this. That's pushing on the coil, just physically squeezing the transformer. And I'm measuring between, I got the secondary disconnected, both sides of the secondary disconnected, and I'm just measuring between one side of the secondary and ground. And look at this thing. It's just me pushing on the core. It's just me squeezing the coil here. So unfortunately this transformer has EOL'd, and I'm sorry to report that's the end of the line for the radio. So maybe someone would want to pay shipping or buy it or something for parts, because looks like the transformer is well aged. It looks like this set has a lot of hours on it. There's some rust. You can see from the discoloration that the transformer has a lot of hours on it. Must have been in a damp environment, and I would have liked to have seen this work. I really would have, just for the entertainment value, but you get a failure like this, it's not worth my time and effort to try and fix it. It is only it's a very simple thing. I think it's probably about 6.3 volts and 280 volts or something like that. But yeah, this thing is, let's see, let's look at the ohms. 470 ohms. Look at that, I squeeze it. Oh, look at that, 170 ohms. No wonder why it's sizzling and smoking, and yep, it's shot. It's shot. So looking at the schematic here, it's a pretty simple transformer actually. It's 265 volts, which connects, that's the selenium bridge right there. And then it looks like we got 6 volts here just for the filaments. Now I don't understand what all this other garbage here is. And you know, tubes are not that picky. I might have something, old transformer out of a color TV or something. Yeah, put this big honking 450 watt transformer in there, because I think I pulled some transformers out of some sets that were used a voltage doubler. I don't know. I'll have to. I would just like to see it work. I don't even care about the radio at this point. I'm just interested in seeing it work. But I am interested in what is all of this? What is all of this stuff here? Is that, what are all these switches? Is that a light? Is that what that symbol is? 2 times 7 volt, 300 milliamp. And here's your valve filaments. Let's use the proper terminology. These are valves. Actually, I don't agree with calling them valves, because valves are used to regulate and limit, and tubes or valves or whatever these things are have gain. You think of a valve, a water valve or something like that, it doesn't have gain. Tubes have gain, they have amplification. And I don't need all of this 50 different countries. I don't care about that. All I need is B plus and filaments. Let me think about this. I think I'm going to call this part 1. I'm not sure. I got to think about this, because I did order this valve because it was bad. They were cheap, but this one tested real weak. So let me see what I can come up with. I don't know if I'll do this in 2 parts or what. One more note. This is why you'll never hear me make fun of series string sets or say that I prefer transformer sets over series string, because series string sets will never have a power transformer failure. So I don't have a problem with series string sets. Not at all. They're much easier repairable and much easier to obtain parts for. These things are tough to find. They're pricey. I could find one, but it's going to cost me money. Day number 2. Thought about this overnight. Let's go over what's happened now. Grid capacitor to this was leaky, causing this to overheat. This tube is destroyed. Tests good, but after it runs for 4 or 5 minutes, it starts to get super leaky. It's a common fault I see on output tubes. It's not really too detectable unless they're in circuit. Power transformer failed. Secondary winding shorted to the case. You can see the discoloration there. Blew the fuse, played with it. What I came up with, or what I found, this is a power transformer out of a Packard Bell 98C22 color hybrid set. And this thing has an output of about a little over 300 volts. So what I did is it also has a secondary that's a 50 volt for the solid state part of the set. So what I ended up doing is creating a buck boost situation, wiring some of the coils in phase and out of phase to get close to the right voltage. This uses 260 volts into that selenium thing right there. I ordered some Soviet replacements of the EL84 6BQ5. I'm going to fire it up right now, and we're going to put the signal tracer on the output of the FM tuner just to see if there's anything coming out of the FM tuner because this thing is stone dead. I would assume this piece of coax here coming from the tuner, the FM, looks like the FM tuner, is the IF, and I'm not getting anything out of there on the signal tracer. I opened the tuner up, and it appears there's only this piece of coax here coming out of the tuner, which would be the IF, and then this wire right here, which is B+, which goes to that discolored resistor, and there's only 800 millivolts coming to this tuner. That's why it's dead. It's not getting any power. Now I wonder if that's in the switches or what that is, but that would make sense why the tube's not getting very warm too. I've literally been looking at this and tracing stuff for an hour or more, and I'm not getting any power to the tuner, and I'm not getting any power to the first IF tube / I think it's the AM converter. And this thing is absolutely driving me out of my mind. And I noticed that disc capacitor right there. And you can see that is not original. That's been soldered on. And the schematic here shows all of these voltages that are missing coming through a standby. All of these voltages that are missing are coming through that 500 ohm resistor right there. And that would be the disc capacitor right there, that one that says 5N. And I have been over this over and over and over, and the schematic is dead accurate, and that resistor is nowhere to be found. It's completely missing. Now, I don't know if that capacitor shorted and they replaced the capacitor and never got around to getting the resistor. I don't know. I cannot find this 500 ohm resistor anywhere. I've traced this thing up and down, and it all makes sense. That resistor is not in this radio. And I think the reason why it's not working is the resistor is missing. And to even take this one step further, see this wire that's cut off here? See that lead? That lead is the hot side. So that resistor should go between this cut off lead and where this capacitor is bodged on. Someone took the resistor out. How many hours have I spent trying to figure that out? You get a second-hand radio and you get one part missing, and to top it off, it's German, so you don't have good service data like we have on stuff here with Sam's. Wow. Let me get a resistor and let's see if this thing wakes up. Oh boy. Oh boy. Smoke started coming out of about 5 different places. Oh boy. This one started smoking. Woo, baby, is that hot. But I had voltage on the tuner, so what is going on here? Okay, we've definitely got some carbon tracking or something in this switch, because watch this when I plug this in. Oh, it's not as bad as it was. Crap. I got this resistor smoking here. Oh, man. Alright, it's starting to make more sense to me now what's going on. Here's what's going on. This resistor here is smoking because this is the resistor that goes from the main B plus cap to the B supply cap. Then the B supply connects to this, and then from this it feeds the IF and the tuner circuit. But here's the problem. There's carbon tracking in this switch, and it's basically loading the hell out of this side of the resistor. That's why the resistor's out. He was probably using it, whoever had it was probably using it for a phono amp or something, and just had all this disconnected. Maybe, I don't know. But I have a feeling that the reason why this is smoking is because it's not supposed to have voltage applied to it that's leaking through carbon tracking here. So I think, man, this thing is a endless pit. Probably the switch thing needs to come apart and be cleaned out. Once they start arcing, you got to really kind of, you know, physically scrape them. Next step is I'm going to disconnect and try and remove the switch assembly. I'm going to get this out of the way so I don't break it. I might even remove the glass, because if I crack that, it's done. I talked to a friend of mine who worked on a lot of these, and he said that the power transformer is a common failure, and that you can order that from that place in Tempe, Arizona. I think it's Antique Electronics Supply. So I'm going to put down the camera. It'll probably take me 3 or 4 days to get this switch assembly out. There's some screws way down under here. Then I got to disconnect all the wires, and it looks like I can hinge it out and maybe get it apart. I really believe there's carbon tracking in one of those switches. And so yeah, we'll see when we get the switch assembly out or destroy it. I'm committed now. I've already ordered parts for this thing, tubes I didn't have and stuff, because now it's just about seeing it work. Okay, back on this. I don't know where I left off, but I'll tell you what I've done. I've disconnected everything, and my attempt is to, what I'm going to attempt is to pull the switch assembly down and disassemble it. I talked to a friend of mine who worked on these radios back when they were popular and common, and he said yes, the switch assembly is a major problem source for these radios, because it's switching, you know, high voltage. When you switch it with the power on, it's arcing inside, so it's throwing little bits of metal around and that, so he could see how it could carbon track. Now what I've done is I've desoldered everything, and I've gotten this thing to a point to where I believe it will hinge open. So hopefully, because this is not running through there, hopefully if I can get the screws out of the top, we can hinge it open, and then we could get it apart. I just, if I can't get it from the top, I don't see how it's possible to get it apart from the bottom without totally disassembling it. And boy, what a nightmare that would be. And you see all of these alignment points are waxed, and with no schematic and no instructions, I don't see how I could ever effectively align this thing. I just don't. I did change cameras. This one's going to have louder audio. This one's only 30 frames per second, so not that anyone needs to watch a repair video in 60 frames a second, but okay. So let me see if I can get this switch assembly out, and we'll try and fix it. Okay, so I pull out 5 screws. I pull out one there. This one here had a solid washer. This one here, copper, and then 2 up front here. These are kind of hard to get out. They're back behind here. So it looks like it's loose now. At this point, I'm really kind of struggling with this. I'm trying to figure out how you get this apart, because it's not really made to be serviced, and as a lot of this is crimped together. Disconnecting this whole switch and pulling it out, I think, is a bit out of the question. The thing will probably end up in the trash before that, but you can kind of see the dirty condition it's in. I was hoping I could get these wafers out so I could get in there and clean it, but even with that, the access is going to be so limited that I just don't know. Taking this side out is really a no-go. If it had to come to that, I don't think the thing would ever work again. If you just look at how much there is here and how much would have to be removed, it just doesn't seem like it would survive that. Okay, I think I'm finally getting somewhere. You got to be careful because all this crap is spring-loaded, but I popped this E-clip off of there, this little clip here, and then pushed that through, and then I took the bar with the switch lock off the top and pushed it through, and now I've got I got this to where it'll come off. Now, I definitely do not see what I would consider carbon tracking unless it's this right here, and you can see that that is on the side too in some spots, but in here I don't see anything. I guess the trick would be to power it up and see where it's smoking from, because it was definitely pouring smoke out of this hole right here out the back. So I do have a transformer. I guess I could do that. Guess I could take my ohm meter and see if that is conductive too, but these don't look like they would be problematic. They really don't. And they're silver contact switches. They look, you know, fairly decent, so I don't get it. I'm sure it would be apparent with 250 volts applied. I'm just not seeing carbon tracking. I mean, these look like they need to be manually cleaned. Maybe that's part of the problem. It's just high resistance, so I'll clean that up as I put it back together, but I'm not finding any low resistance carbon tracking. These clean up very nicely with the Dremel and the wire wheel, and some of these you can see are actually pitted. It's silver, looks like it's silver plated brass or something. Very nicely made, but worn out. Where I'm stuck with this is this resistor right here is burning. Right? You can see that 10K is burning. And this is going to be hard to explain, but basically this is the 10K right here. And in all modes except FM and phono, you can see this is grounded, and I'm sure what this is this is some type of tone control, like a low-pass filter that cuts the high end off in AM and shortwave, so you don't hear all the squealing and that. So basically, this thing is getting 200 volts right here. It is not coming through this capacitor. It has got to be leaking through this switch somehow, and I'm not seeing it. I'm not figuring it out. This is the ground bus right here. I just don't get it. I'm completely stumped on it. It's got to be in the switch. And it is absolutely leaking through 2 pins of the switch. You can see I disconnected the wire there that goes over to this resistor, and all that should do is pull that to ground. The ground bus is in front of it there. And I didn't see this when I was in there, but this is the ground bus. This goes, ow, shit, this thing is hot. This is the ground bus, and I unplugged it. His filter's charged up. I should discharge it. It's discharged now. I've been shocked so many times I don't even do much more than curse anymore. So this is 280 back here, and it's leaking between those two pins. And sure as hell, we have got to have a carbon track right there. Come on, focus. And I'll show you what I mean. So, oh crap. Okay, so the one that's disconnected is pin 4 from the back. So 1, 2, 3, 4. Okay, this is the one in front of it. So this is ground. So it being shorted to this one automatically runs through the capacitor back to this one. That's why it beeps. Am I covering the microphones? Let's try that. Okay, so 1, 2, 3, 4. Let's try and do this here. 1, 2, 3, 4. 0 volts short. 1, 2, 3. Oh, now you're not going to be shorted, huh? It's all over the place now. But 4 is completely disconnected. So it's got to be something right in between here. Let's clean it up. Well, I have tried everything to clean that, and you can see there where it almost seems better like that. You can see there where there is literally a hole burnt between 3 and 4, and I am thinking about this. What do I do with this? Because if I drill a hole there, then the pins will lose their support. It's just carbon arced between, it's carbonized between those two pins. And how do I deal with this? Well, if I disconnect that, that pin goes, let me think about this. So the purpose of this is, like I said earlier, in FM and in phono, and maybe in tape, I think, those 3 switches right there open and allow more high end. So it's basically a low pass filter. When you shunt the bottom of that 500 ohm directly to ground through those switches, then you cut the high end off, which you would probably want for AM and shortwave, because you want to cut the whistling and high-pitched squeal and all that down. So if I just leave this damn thing open, if I just disconnect that wire and leave it open, then it will not go to ground. So what would happen then is you'd have more high end on AM and whatever. I think that's just a better option than trying to screw with this switch. I knew it was carbon tracking. I didn't quite know where and how accessible it would be, but it's right there where that little hole is. Come on, focus. See that little hole between those two pins? That, if I powered it up, we would see it arcing and smoking right there. In fact, I might just do that. Never mind, I can't. I have the wire disconnected. I've mostly reassembled this thing, and with it, I'm running it off this. This thing goes from 110 to 240 to 480 to 220, depending on how you wire it. Actually, it's 480 to 240, or 240 to 120, or 480 to 120. And I have it set up for 120 to 240. And basically, I have 280 volts. I do not have the filaments lit, and I have this tube missing. And I have 280 volts through the whole thing with no arcing or smoking or anything. So I'm thinking that it is ready to roll. So I'm still getting carbon tracking somewhere else in the switch, because if I go to AM, the B plus drops and it starts to smoke out of the switch. So if I go to FM though, I go up to 280 volts. 186 volts. So something happens when I let that switch loose. Something else is arcing in there, and I just put this damn thing all back together. Alright, I believe I got it, and it's just my analog switch logic brain was brain dead. So I had this pin right here, which was carbon arcing, it's under this resistor, was carbon arcing to this one. So what would happen is when I would switch to AM or another band, when it would go to ground that pin, even though the wire was disconnected, it was tying it. There I go again, getting shocked. Damn, no tube filaments, so the doesn't drain the voltage off. So you can see what I did. I lifted the ground up out of there, and I moved this resistor, which was grounded there, over here. So no more short, no more smoking resistors, no more smoking switch. It's just that one single carbon arc spot right there that you saw that's causing, I believe, all of these problems, and why the previous owner disconnected, pulled that resistor out of there. We'll get the tubes back in it, and I bet it works. I believe I did this earlier in the video. I wanted to see if the FM tuner was working, so I brought the signal tracer out and probed this line right here, this coaxial line, which is basically the IF out of the tuner. So what I've done now, I wanted to just see if it was working now that we got B plus, because it's not shorted out and a missing resistor, etc. So going through these two IF transformers, and I can't probe it here because it's basically feeding the voltage through this resistor, through this IF transformer up to the tuner, but I got it probed on the output of the IF transformer, which would be the control grid of the first FMIF, and we got workage. That noise is that is the phone. That is the cellular telephone doing that. Why it's doing that, I don't know, but that's how much gain this signal tracer has.
Learn. No.
So that's pretty good, because I have That's no IF. That's just straight out of the tuner. So it's gonna sound like crap, and I'm surprised it even works that well. What I'm using is I'm just using a 12.6 volt center tap filament transformer for the filaments, and the 110 to 220, which is not enough power, not enough voltage. Once I got the tubes out, once I got the tubes in, the voltage dropped kind of low. It's at about 220. The EL84 wants to see 250, so I'm a little bit under, so I'm going to have to deal with that. But it's working. Just need to get, I left the tube somewhere else. I'll get that tomorrow, so there you go. What passes for music these days? You know, that song is in every single radio video I do, Rock With You by Michael Jackson. My point in pulling that tube out was the voltage would go up, and I wanted to see how much of a difference there was. Because that takes the load off the B+, and that's the leaky output tube. Alright, we're reassembling everything here, and it's a good thing that I took pictures of the way everything was routed. Another note, I took pictures of these with the phone, and then the phone crashed. So it was a good thing that I backed all my pictures up to the computer on a weekly basis, because I would have lost all of this had I not done that. It's a pretty new phone too. It's just infant mortality, you know, something's going to die in the first 10% of its life or the last 10%. So always got to make sure you back your data up, because if I had lost these pictures, I would have never got this thing routed exactly the same way it was. And I want to try and keep the lead dress the same, because I can't really align this thing. No instructions, and everything's plugged with wax. Alright, well, this thing was working. It was actually feeding a signal into a speaker. It was very low and muffled and distorted. With my ear on the speaker, I could barely hear it. Then I noticed the 6BQ5 EL84 was arcing inside. That's kind of as we expected when it got hot. And then it kind of died, and this resistor right here started smoking. And at this point, there's very few resistors left in this set that have not smoked. And so I started to look at the schematic, and that resistor is at 5K right there. And if we follow that up, we come to two capacitors, 100 picofarad and a 2.2 nanofarad. And the 2.2 nanofarad goes to the plate. So I would automatically, looking at this, I would suspect that that capacitor, that 2.2, would have to short and dump that 270 volt or 261 volt plate voltage onto that resistor, which is exactly what happened. And that capacitor is like buried way down in here. And I'll measure it with the ohm meter. And you can see it's measuring about 1 ohm. Now this is acceptable, you know, for a capacitor to short. This is kind of radio 101, so radio repair 101. So I'll go ahead and wonder what this is a piece of that it fell out of here. Okay, you can hear it. It's almost like I got the speaker hooked up to the wrong leads. Oh, that's awesome. Maybe that's because I cut that tone compensation capacitor out of there. It's feeding back now. I can hear the audio coming out of the audio output transformer. Wonder why it's not driving the speaker.
A dairy farmer got a text from one of his cows.
Holy shit, it works. Oh yeah.
Between 104 to 108, up to 112 into the high deserts as well. Features right around 80 downtown, close to 90 degrees. With Southern California's most accurate and dependable forecast, I'm CBS 2's Garth Kemp, KNX 1070 News Radio. 83 right now in Corona. We have got 75 in Whittier, currently 78. Los Angeles at 1046. The mayor of Los Angeles.
I'll admit I didn't solder any of these wires. They're just stuck there.
57, you'll be tapping the brakes. The #1 selling pickup.
Oh, I love that. That is just, let's just bask in that for a minute.
Sailors, I can't believe.
So,
I'm sorry.
this squealing could be that capacitor, that tone compensation capacitor off the plate I just cut out, but it could also be the fact that I disabled that tone compensation resistor thing that kicks in, because watch this.
Your officer was asleep at the end. This is all we depend on for a destroyer not to be destroyed?
This is the treble.
I will tell you this much. I was actually on board one shift during my reserve duties where a junior officer almost did.
This could be the point of that thing in the switch that was shorted out that I disabled. I tried changing this valve with another ECH81. That one checked dead. I don't notice any difference in the performance. Okay, I got this thing working. You can see what this does. That's FM, that's AM. So you can see what it does is it engages and disengages the different dial cords. So when you're on AM, you can see it engages that one. When you go to FM, you can see it engages that one. That's kind of a cool feature. We got something else providing a fireworks show under here. The hell is this? Okay, so what is arcing in here? I had to turn it off for a minute and now it's stopped, but I don't see anything. That capacitor is just cathode bypass, I don't see how that could arc. It's got about 5 volts on it, 9 volts. What is... Well, our cathode is reading, it's kind of bouncing around, but 5.8, that's kind of low. And I am running this on a kind of a low B plus right now, but I still have no idea what was arcing here. I can't see that electrolytic arcing like that in, you know, an aluminum can. So maybe it shorted, I don't know. It hasn't arced since, so I don't know what's going on. This is Ariana Grande, right? If the radio is going to blow up, it should blow up right now. Pretty interesting how this radio just seems to have cured itself. The audio output tube is stable now, and I saw it arcing inside earlier. Whatever was arcing down here is stopped. Self-correcting. I don't get it. Russian Soviet 6BQ5 EL84s came. So let's open this up and see how these work. Check out the way people from other countries pack stuff. They just don't like throw it in a box and hope UPS will treat it gently. They actually take some time and put some effort into trying to satisfy their customer. All right, this is a USSR Russian-made 6P14P, which is the same, should be a direct drop-in for EL84 6BQ5. So at the 6BQ5 that's in there, our cathode voltage is 6.22. All right, let's see what the 6P14P does.
Eric's whole life was about to go down the drain, so he called Optima Tax Relief.
Optima was able to make sense out of a huge disaster, and Optima stopped it.
To say the least, Eric was very relieved.
They got me out of hot water, that's for sure. Optima saved me a boatload of money.
A little bit less.
6122. Optima Tax Relief.
It's Tom Tran. Hey, home sellers, here are great reasons why you need to call Rudy Kasuma to get your home sold.
I'm sure it's fine. This is not a audiophile thing. It's just a radio. As long as the tube is not arcing inside and burning and shorting out, I think we'll be fine.
Hi there, friend. It's me, Snuggle Bear. I can twerk. Happy Hug Day. And it's free. Let's snuggle. I can also do the Dougie. The Dougie.
Alright, let's go over where I'm at with this thing right now. I replaced this resistor, which was this resistor right here, because this is what was arcing and causing the fireworks show, and this finally went open. This is the capacitor that was shorted here, is one of those ERO ones. So those two have been replaced, and unfortunately when I was changing that resistor, the tube socket broke. The pin pulled right out of the bottom. So what I've done is I've siliconed, I put the pin, I put the female side, I pushed it up on the bottom of the tube, and then I glued it into place with that good gray, high temperature, high strength silicone. I don't know how it's going to work. I should really replace the tube socket. It's just, it looks like a major headache. So, at this point, who knows, probably technically every one of these capacitors needs to be changed. I did put the proper 500 ohm resistor in here. So I guess I could cut this out. I'm using a this is a power transformer out of a Packard Bell color television that I scrapped out. It was one of those new old stock deals. And basically I've configured this the best I could in a buck situation where I've got, or configuration where I've got the main B plus winding, which is about 300 volts, and then it's about 300 volts, and then I got a 24 volt secondary winding on this transformer that was for the solid state part of this hybrid set. So I've got that wired, I guess it would be in phase or out of phase, I don't know, but so it cancels, so it takes basically 25 volts away from the 300, and then I got an auxiliary 6.3 volt winding, which was for the high voltage regulator tube on the set, and I got that one wired the same way, so it's bucking basically 30 volts off of the 300, so that leaves me 270, and then these resistors drop me down to about 240 with the set running, which is where I need to be. So I'm going to let the set run today and see how it performs, see what else shorts or arcs or smokes, and then we'll go from there. So unlike transistors, tubes, the current draw, DC current draw goes down the more AC, the hotter the signal, because watch this, I'll crank it, cathode voltage will drop. So, seems like the tube would last longer with a hotter signal through it. Wanted to take a second and talk about power supplies with this Grundig radio. So this is one option that I've been thinking about. This is basically a capacitor doubler circuit. So your line comes in here, and ignore this down here. This is a series string filament. This is just in a television, but all computer power supplies use this basically too. So you come in through a capacitor in series, and then you got a couple diodes and another capacitor, and this essentially doubles the line voltage. Now this will work, except this is a hot chassis set, and you know, if you ever connected something like a record player or an iPod or something, you could get a potential ground loop through this thing that would cause an explosion or a fire or something else. Now with the transformer, this is just an example of what I was talking about using a bucking configuration. So this is like the television set transformer I'm using right now. So you got your 117 primary, then you got your 300 volt secondary, a 50 volt secondary for your solid state stuff. This was out of a hybrid set, and then you got your 6.3 for your tube filaments. Actually I got two 6.3s on here. So I was talking about in the bucking configuration, if you were to wire this like this, then you would have out of here, you would have 350, right? But if you were to wire this like this, so that one's connected to there, and then this one comes out here, then basically here you would have 250. So you'd be wiring this one, I don't know if I want to say in phase or out of phase. Let's just say out of phase, so that the 50 volts is canceling the 300 volts. It's not adding to the 300 volts. That makes sense. I know my drawing is really sloppy. Maybe this is a little bit better of a drawing. So 300 plus 50 equals 350. 300 minus 50 equals 250. I guess one consideration here would be, is the insulation breakdown in the transformer consistent enough to handle that kind of potential on the 50 volt winding up against the 300 or the 110, depending on how it's laid out in there. I would think so, and if it does fail, it's not really a big deal. I should probably fuse the input of this, put a fuse in here just in case something was to short, but the radio actually sounds and performs so good I might actually spend the $50 and buy the transformer for it. I just got to think about it, because it's a lot of money for something that probably won't get used that much, and I've already gone pretty far. Here's a look at the dead eye tube at night. Very dead. And I can't even find this on eBay or anywhere. Very rare. Doing a little bit of measuring here. I'm just trying to find a suitable replacement for this transformer that's not super expensive. And 90 milliamps is the basically the B plus AC load. Let's see if we crank it up. And you can see, like I said, unlike solid state, the current consumption drops when you drive the amp real hard. I know that's contrary to the way things work now, but that's tube equipment. So this is about what I need right here. 6.3 volts at 4 amps, 250 volts at 120 milliamps. Looks about right, you know, from Taiwan. 20 bucks, that seems about legit, right? And then you go in here and you look at this and look at the shipping. $42.50, so you do 60 bucks for this thing. There's a lot of other selections here, you know, like this one, 150 milliamps, that would be okay. That'd be a little bit over, but there you get your $42 shipping again. So, you know, I could pop that for free shipping. So let's see what we got here. $25 with $20 shipping. And secondary voltages are 250, 0, 250. That would be okay. But again, you're talking, you know, 50 bucks by the time you get $20 and $25. You're talking 50 bucks by the time you get it here. That's just, you know, more than I really want to spend on this radio, and most people would be willing to spend on this radio. Here's one from Hong Kong, which is like a, whatever they call this, an R-core transformer. So the way I came up with this search was, here's what I searched. 250 volts, 6.3 volt secondary transformer. All right, well, it just died. Say we're about 16 hours into it running, maybe a little bit more, and I just heard a pop and the music stopped. What's funny is we're still drawing 87 milliamps, which is the way I still had the meter hooked up from earlier when I was checking the draw on the transformer. So it's dead on AM. It's just dead. Just silent. There's activity from the amplifier when I touch the control grid, so it's almost like the IF died or something, because it obviously drawing that amount of current, it went down about 3 milliamps. Okay, here's something that's kind of interesting. I pull this tube out, we lose 7 milliamps. When I pull this tube here out, we lose nothing. Okay, let's pull this one out. Well, we didn't lose anything, but it made some noise. That must count for something. So on this one, I believe that's an EF89, and so basically we have 230 volts on the plate, and we have 80 volts here on the screen, and we have a 1K resistor here to a 60K. We got a couple capacitors here. It's possible that this one might have shorted, so that would mean some more burnt resistors. You know, I should have changed all of these, I admit that, but I'm so over this radio at this point, and it's kind of interesting to watch the failure pattern. But I ordered my dinner, so I'm gonna go get it. We'll check this out tomorrow. But I'm looking at something here, and I thought before I did go get dinner I would take a look, because these capacitors are known to open and then close or whatever, and let it cool off overnight, and the capacitor would release it short. But you can see there we have another blown resistor, another cremated resistor, and I believe that's that 1K right there. The capacitors are a little bit different on the schematic than in the circuit. They are not two of them in series in the radio like this. Start by getting a little video and a picture of how this is put together. I need to change both of these. You can see they got a ground strap wire wrapped over the top of them. I don't know if that's for RF or what that is, but both of those need to go. And we might have a couple more over here that need to go as well. Alright, these are basically 0.0047, and what I was going to put in here is a, well, 0.047, and it doesn't matter. It wouldn't matter in this case. They're just bypass capacitors. This is 473. That's 47 with 3 zeros. This is 47 with 2 zeros. So this is by a factor of 10 higher, which is fine. It wouldn't matter. But I have to go to the electronics store tomorrow anyway, and I'd like to put disc capacitors in here. So what I've done for right now is I've just clipped that stuff out, and that is the resistor I put in there is a Dale RN70 mil spec resistor from 1967, 1%. I expect this thing just to work fine without the capacitors. I don't know, we'll find out. But you can see how that gray wire there is tucked underneath the ground too. So I really need to get this outside in good lighting and pull the bar antenna off the top and get it sitting on its top, where I can really do some surgery there to change those if I'm going to do a good job. So the next thing I'm going to do is fire it up, and I want to go through all these other capacitors and check which ones have any kind of voltage potential across them, and they're going to get changed as well. If they have more than a couple volts, they're going away. Okay, well, it works, but the gain is greatly reduced. Listen to the difference.
I didn't know that. I met the and we just hit it off. And,
So it makes a huge difference to have that bypass in there pulling that RF to ground. I'm surprised, but you hear it. So yeah, they are necessary, but it works without them. All right, I just tacked that in there for right now. This is an EF89, this tube that we've been dealing with. Oh no, that's the EABC, whatever. That's the thing that's got like 5 elements in it, a bunch of diodes and stuff. Let's try that again. This is the EF89 IF tube. And I was looking at these, and I just, as an experiment, I meant to grab a 6EH7, which is a screen wire plate type IF tube that Zenith uses in the color sets, well, on pretty much all their sets. But I grabbed a 4EH7, and I think this will work in here. Let me bend the pins. Now let's see, this should get nice and bright in here, being a 4-volt tube with this unforgiving big transformer. Well, it works, but it's not nearly as loud. Let's try this other one. Let's try the EF89. Oh yeah. Way louder. Alright, I checked all these other capacitors and none of them have more than a couple volts across them, so they're not going to short, they're not going to be a problem. I pretty much changed out everything except like that one right there is for the tape input. I'll never use that, or the phono input. No voltage across it anyway, and these are just a couple bypass caps here that have no voltage across it. And somewhere in this it appears I lost AM, broadcast reception. FM is working though. I don't know. Would that other capacitor have something to do with it? Why does it look like that slug was driven down when I didn't touch that? Okay, I got the AM working again. It needs both of those capacitors. It's kind of strange, but that the FM would work and not the AM. I guess it's a higher frequency, so it tends to drop off faster. And I actually got K-Surf here, which was the Rat Pack station, but now is Oldies. Just need to get the capacitors and get them installed properly. This is basically the AGC voltage that's coming off of the I-tube. It's kind of interesting to look at. This is KNX. This is how strong this.
Right before Harbor, we've got multi-cars involved in a serious crash.
It's destabilized. Now, because it would repeal the individual mandate immediately without.
Come rain, no come shine. Happy together, unhappy together in one
Kind of gives you an idea of signal strength. Alright, I cleaned this all up. 2 new disc capacitors. Disc capacitors work good in just decoupling stuff like this. I replaced the disc capacitor I had in the audio with a Mylar. That should maybe improve the audio quality. Usually I wouldn't, but since this thing sounds so good. Now the next thing I want to do, these are 2 130 volt Zener diodes in series. And I want to run this from the B plus to ground, because before the filaments heat up, the B plus is up at 360 volts without a load on it. So what these will do, and boy do they get hot fast, you can see we're at 356 volts there with the filaments not lit. And when I put the Zener diodes, see if I could do this without shocking myself. When I put the Zener diodes, it shunts it down to 270. Boy, do they get hot quick. Alright, so once the tubes warm up, it drops to 235 volts anyway, so the Zener diodes just cap it at 260 until the filaments warm up. This is not a good idea, because if one of the tubes was to go bad, the Zener diodes would overheat and short. But for now, until I decide if I want the right power transformer, at least it'll keep the voltage from running away. So I just got those tacked in there right there, just temporarily. Okay, what this is a switching mode power supply. What was this thing? Citybug battery charger. This is your doubler circuit here, and here's your switching transistor that drives the transformer to the low voltage. What I'm going to do is I'm going to try and use this in here as an experiment. Not too safe. I'm going to take it, I'm going to cut the board and just cut the doubler out. So we've got our input, then our filter choke, capacitor, RFI filter, bridge rectifier, doubler capacitors. With no load on this, getting 331 volts. Now I don't know with the load what I'm going to get. I'll have to play with that. Alright, using this solely for filament. I'm using the doubler through a 1K resistor. I've got 258 volts, and this is now a hot chassis set. This black right here, which is connected to the negative of this capacitor, is directly to the line, and the radio is working. Okay, the AM was working and there's no noise, and it seems to be fairly sensitive. We're up to 264 volts now. AM is less load than FM. So what I was thinking about doing just temporarily is using the doubler and using the filament in this transformer and disconnecting the B plus that way, because it was arcing when it was connected to the core. So if there's no reference to ground, it shouldn't arc. Let me think about this, because this makes this a hot chassis set, and that's fine for me because I'm not going to do anything with it. But if it was to ever get handed off to somebody, hot chassis set with a doubler is kind of scary. I gotta say, this is solid as a rock, and the resistor is not nearly as hot as with the transformer because there's not as much voltage drop across it. So yeah, the question is, can I use this for filament still? And how dangerous is this thing gonna get? I gotta play with this. Maybe put fuses on everything That way when it shorts out, it doesn't catch fire. All right, this seems to work. I checked if there was any potential between this thing being grounded and the ground back to the wall from the radio, and I reversed the plug, and it's clean, so there's no kind of leakage or interference here. And so I'm using the original transformer for the filament, and I have, you can see I just have the high voltage leads, a 250 volt secondary from this removed, and I'm feeding the output of our doubler straight into the output, what would be the output of the bridge rectifier. So this essentially gets rid of that bridge rectifier and that filter capacitor. So it's not, definitely not as safe, because we have line potential from the chassis now. There's no isolation, but I think for now, until I decide whether I'm going to spend the money for that expensive transformer, I might just run with this. This thing is small enough I could just stick it back here. I'll fuse it all real low, and we'll just go with it. Alright, well, back to the drawing board. After a few hours of running, this has gotten to the point where it's gotten hot, to the point where I can smell it, and it's burning freaking hot. So, and all I'm using it for is filaments, so unfortunately that was a novel idea that didn't play out real well. Wow, is that hot. So that transformer is just shot. So I can get a filament transformer and a doubler, or I can just spend the $65 and get the right transformer. I don't want to spend that much money on this radio. Transformers.
Oh, the transformer, that's right. You needed 6 volt, 5 amps.
6.3 volts.
Yeah, well, these are 12 or 12.6. I don't know how they count it.
Center tapped, right?
It's going to be a center tap, yeah. So you're going to see 6 on each side. So you can, yeah, you can use each side, yeah.
0612 VAC 3 amps. Mm, 0612. 2 amp, 3 amp. China, made in China. 012. Nothing's cheap anymore. Am I really gonna spend $15 on this junk? Wow, $23. $25. Oh man, China. Wow. I need screw type 6.3 volt. Maybe that one right there.
is that? You don't need a power supply? No. So just this. Like,
Instead of a 1K, I'm going to do a 470 and a 560. Actually, what is this one right here? 675. Okay, I found a couple triad 12.6 center tapped 2.5 amps. That should be enough. Much better, American made. We'll go with these. Alright, here's the original transformer. There's the doubler. There's the 2.5 amp triad transformer. And these are a bunch of pico fuses. Let me see what I can do to configure to get this mounted in here. Come on, focus. You gonna start this crap? Okay, let's go over what we ended up with here. So here's the old Grundig transformer that's shorted and failed. So here's what we've come up with. This is our new, this is a FX26 12.6 volt center tap, 2.5 amps. I mounted it to the brackets for the old transformer. You can see it's mounted here and down here. This is our capacitor voltage doubler out of the City Bug. I used nylon screws, non-conductive, and nylon, actually those are Teflon standoffs. And so I've got the board mounted here and here. Here's our 1K dropping resistor. I was going to go with two 560s to kind of relieve some of the heat, but this just looks cleaner and fits better. I'm only using one leg of this. The other leg is just terminated and shrink wrapped off right there. That's the 12.6 volt. As far as fuses go, I've got this fused on both legs, one fuse here, the other original fuse here, and I have the filament transformer fused off at 1 amp here. This is a pico fuse, 1 amp, and of course this fuse too. So everything is fused on both sides of the line. I guess now to try it and see if it works. Take a look at how that ended up. Well, two of the light bulbs I got were wrong. I guess those were mislabeled in the box. Filament voltage is 11, a little bit high, 7.1. That's a little bit higher than I'd like to see it. The B plus is good, but that transformer's putting out a little bit more than I'd like to see. I got to think about that for a while. The other smaller transformer was about right. But do I want to undo this for that? I don't know. At least it's not even getting warm, but the tubes are, it's hitting the tubes pretty hard, a volt high. Okay, my filament voltage, when I put both light bulbs in, and the eye tube, which is dead, but at least the filament adds some load. I brought the filament down to 6.9, so it's still 600 millivolts too high, but I'm not going to worry about it. Doesn't seem to be glowing all that bright. Probably shorten the life a little bit. So I think it's time to put this back in the cabinet. Now I would like to say that none of these values that are arbitrary or guessed. They're all calculated out. Like for instance, that 1 amp pico fuse there, what I did is I put the amp meter on the primary and I shorted the secondary, and I wanted to see how much current it draw. And it was drawing about 1.5 amps. That's why I chose an amp, because if the output of this ever was to short, it would blow that fuse. Same thing with this. I measured the surge voltage with dead capacitors with this all hooked up. That's how I came up with that value. So none of these values are arbitrary. They're all kind of based on some testing And overall, the B plus and the filament's a little bit high. This would operate probably better on 110 volts than 122, which is probably what it is here. The line voltage seems to have gone up. Must be all that solar energy we got now. Anyway, let's put it back in the cabinet and I'm done with it. Well, amazing. I put it all back together, soldered the speaker connections back on, and it worked great for a minute. And it just stopped, and now it's just dead. There is some hum coming out of the speaker, but I don't get it, man. This has been the toughest. Okay, what the hell is going on here?
Grab a refreshing
Class.
I took her around the way.
She loves me, and I'm single solitary. We just to the party, and if you didn't know, you should have asked somebody.
Hey Ed, remember this song if you got this far into the video, the instrumental?
I think about Madonna, I think about
Give that number a call, 800-499-1658. That's
18 pieces for only $11.99. You'll also find especially true when it comes to the BMW 3.
Or then, when I have a Sunday fun day at the
Let's turn on the cameras and so forth. And I'm telling you that it's
I would say give us the 10% that you took from us from the beginning. That $1 billion that you say goes to your stadiums, which has nothing to do with the players.
I don't know if shortwave works. I don't care if shortwave works. Shortwave is dead in my opinion. I don't have an antenna on it anyway. Sounds like it's awake though. Let me see if I can get an antenna on it. Yeah, shortwave works. I only got a clip lead on it.
Gigantic heathen temple, and God destroyed all the pagans and the heathens, and the scripture says Samson in his death. My demise is near. I've quoted so many times. I'm 84 years old. I didn't expect to live this long, and a long time it's been prophesied.
So it works. It all works.
Ex-lead singer of La Excelencia.
On the darkest day, moms who get their mom.
What has this been, 2 hours? It sounds really good. It's hi-fi. I would give it that. It sounds at least as good as that RCA orthophonic thing I got. That big, huge radio that's about the same size. So if you made it all the way to the end, you're my hero. Thanks for watching, and there it is, Grundig 3035. This is a bucking transformer. I have this configured. Actually made this for color TV, so it's knocking 10 volts off the line and brings it down from about 122, 23 to 100 and about 14 or 15, which is, remember, this transformer was 115 to 6.3, 12.6. So the line voltage just seems to keep getting higher and higher, which doesn't matter to most switching supplies now, but it does matter to this old tube stuff. And with the voltage at 114, the filament voltage is right on 6.25. So just line voltage is kind of high.
Right off into the sunset.